All right, I goofed up. I forgot to start up my Camtasia screen capturing product rather. So what we're going to do right now is we are going to start going through Chapter 5. Shorter than the previous chapter. We're going to talk Boolean expressions in just a moment. Then we're going to talk conditional statements and expressions, then loops. Then we'll look at a brand new application called future value. We'll do that momentarily. What I'm going to do is I'm going to go back and forth between this, and I went into Visual Studio and I created a brand new project that I just called Chapter 5 to demonstrate some of this stuff. All right. So with that said, the first thing that we're going to do in here, when I go back to the book, is we're going to talk about relational operators. All right. And I'm just going to very quickly, you'll notice that there are 6 of them. So I don't know if it'll let me, the copy feature on this, on what I'm using here, it just stinks. All right, so let me do this. It'll be much easier. Just do it right here. Stop already. Again, sometimes this keyboard just drives me nuts. All right, these, and you're going to see them again in just one second. What I'm showing you here are our 6 relational operators. All right, I'm going to throw them into my file here as a comment. All right, so there they are. In just a moment, we're going to do our other operators. I don't remember what they're called, but we'll grab them as logical operators. And we'll grab those in a couple minutes. Now, I'm going to just do this right here in the comment form. So if I were to come in here, in fact, I can do this. I can do it right here. And I'm going to say int number1 or num1 equals 5. Int num2 equals 10. All right, these mean nothing. And I'm going to remove this fairly quickly. But what can I do here? Well, if I say num1 is equal to num2, are they equal to one another? So if I put this in an if statement, and I said if num1 equal num2, you should know by looking at that it is false. They're not equal to one another. If I say this, if num1 is not equal to num2, then you should automatically know that that's true. All right. If I say, let me just, when I get done with these, I'll comment all of them out. So if I say if num1 is less than num2, you'll know that that is true. All right. If I say, just put the rest of them in here. Oh, I hate that. All right. All right. If I say if num1 is less than or equal to num2, that's true. If I say if num1 is greater than num2, well, you should know already that that is false. If I say greater than or equal to, all right, that's also false. And I guess I made one too many of these. So my question for those of you watching as I comment this back out, which is what I'm going to do right now. Well, I don't have my comment things in here. Not a problem. Just do it manually. Is there anything that's in here that does not make sense to any of you watching? Again, if it's silent, I'm cool with that. We do not have a triple equal sign in C# like we have in JavaScript. So no one's asked that, but just so you know. So again, these are our relational operators. We are relating two things together. And unless there's questions, all right, I'm going to go on. Now, in your book, they show it and they give examples. But there's nothing in there really that I haven't already gone over. All right? So next are our logical operators. All right? And I'm going to do the same kind of thing I just did. I think there's 5 of those. Yep, there are. All right, so let me grab those. All right, and we will talk about our, so this was our relational operators. And now we're about to come in here and do something similar, but we're going to talk about our logical operators. I don't want, well, just do it like this. There we go. All right. And again, our logical operators are these 5. All right. There are differences between all of them. I'm going to show you all of them right now. In the same way, when I get done showing you these, if there are any questions, then please stop me. All right. Before we go on. So I want to show you and, or, and not. You say, what do you mean and twice? I'm going to show you right now. Now, usually when you're doing logical operators like this, you're making a double comparison. So if I came through here and I said this, notice we still have our num1 and num2. All right, I'm going to say here, if num1 is less than 10 and num2 is greater than or equal to 10. Now, I want you to look at that, and can somebody tell me, is that particular statement true or is that particular statement false? Anybody?
It's true.
You are correct. It is true. Now, I want to take just a moment here and explain to you the difference between this and this. Whoops. And this. This one right here is also true. But the way that C# works, and it's the way most programming languages work, is when you use the double like this, it does what's called short circuiting. So let's say I did this. Let's just pretend I did that now. All right? Well, num1, is num1 greater than 10? No, because it's 5, right? So with a double ampersand there, it only does this comparison. It says, since that one's false, it doesn't matter what that one is. So with short circuiting, it only checks one side on an and if the first thing before the and sign is false, because it doesn't have to check the other side. All right? We'll talk about ors in just a minute. Now, with this one, when you put just a single ampersand in, it checks both sides regardless. It always does. So the difference between this and this is using the double short circuits. So in the case of an and, if the first and condition is false, it does not check the and second one because there's no sense in checking it. Since the first was false, it doesn't matter if the second is false or true. With the second example here, all right, it does it, for lack of better words, it just does it anyway. Now I'm going to grab these and I'm going to put them in here. Why? So I can put them in here too. All right. And we can keep going down in here. So that was the and. So and is basically everything has got to be true in the and. So everything must be true here for this and for this. Or anything must be true. So with the or, I'm going to make one change in here. And that is, I'm going to say, I will make this greater than. Now, this is false. But this is true. With an or, as long as anything on either the left or the right of the or sign is true, the whole thing is true. All right? So that's the difference. And it short circuits just like the and did. And if I leave this as a less than, so we'll move that back to a less than again. So since num1 is less than 10, it never checks that side in an or. When you use the single pipe sign, it always checks checks both sides of the single pipe sign, regardless of whether the first one was true or whether the first one is false. All right? Now, with the not, I'm going to keep this simple. You know this already if I say if num1 is less than 10. We already looked at this. And you already said that that was true. And it is. Because it's 5, and 5 is less than 10. All right? If I put a not sign in here, that basically inverts it. That's the same thing as though I said if num1 is greater than or equal to 10. So using the not sign, it's typically referred to as being an inverter. It's an inverter. So it takes something that was true and it makes it false. It takes something that was false and makes it true. All right, so for example, if I had a Boolean variable there that was called is married, and if I typed in is married, so let's do that. Let's add a Boolean here. And we'll call it is married. And we're going to set it equal to true, just so it's got a value. So if I come through here and I say, if is married, we already talked about this before, that's the equivalent of saying, so that's the same as if is married equal true. All right? On the other hand, and you can already probably figure out what's happening here, if we say if not is married, that's the same thing as saying if is married equal false. All right? So those are your relational operators and your logical operators. Does anyone have any question on either type of operator? All right, hearing none. So we have now talked about relational operators. We have now talked about logical operators. I'm going to leave all these in there just so you can see them. So the program will get longer, but as I go through stuff, I'm just going to comment it out. All right? So in our book, they explained all this. All right? And then they talked next, they're going to get into if-else. We're going to do that in just a moment. I'm going to go through my own little shtick on this. The only other thing I want to mention that I didn't is if I have a really big statement like if num1 is greater than num2, and I like to put each thing in their own parens and then put parens around everything, and num2 is greater than 6, or not, I don't know, that doesn't make much sense, or not num2, something like num1, that's fine. Don't worry about what this means. All I want to show you is the order of operations. In fact, I'll leave these parens out. When you've got ands, and you've got ors, and you've got nots, they're always done in this order. You do the nots first, then you do the ands, then you do the ors. So in other words, first you do the nots, which are these, then you do the ands, which are these, then you do the ors, which are these. And that actually should make sense to you because putting a not in front of it is the most exclusive. It's that thing that you can do. Sometimes you can look at it, it's the most conservative thing you can do. Putting an or around it is the most liberal thing to do because this always changes the value from true to false or false to true. This says that both sides have to be true. This says that either side has to be true or both. All right? So I'm going to come in here. Now I am going to put in some code. So I'm going to leave all that stuff there, and I'm going to put in some code. All right? And I'm going to put in here int size. And I'm going to set size. I don't want, well, I can make it an int. Let's make it a string because it'll probably be a little easier. So size, and I'm going to set it equal to m, meaning that it's medium. We're going to suppose in here, so I'm going to assume sizes are small, medium, large, and extra large. Now, hopefully I don't have to write down another comment line that says that's SMALL, that's MEDIUM, etc. Hopefully that makes sense to everyone. All right? So I can come through here now and check for all four of these sizes. And I'm going to show you, first I can do this. What if I only care whether or not you're a small? That's all I care about. So I'm going to come in here and say if size equals S. And I'm going to put in here, I'm going to do a right line. You are a small. Again, I'm going to keep saying this, but I'm asking the question. If you get it, just don't answer me my question. Does this make sense to everyone that nothing will print right there? Does that make sense to you? Okay, let's go on and add this. So I'm going to say else, and I'm going to leave it like that for now, just else, and I'm going to do a right line in here. I'm going to change this in just a moment, but else I'm going to say you are not a small. Does everybody understand this? In the current situation, considering we've set size to M, this is going to print out you are not a small. Does that make sense to everyone? All right, either in the current format, either line 58 must print or line 62 must print. One of those two lines must print. Only one of those lines can print. Does that make sense to everyone? All right, then let's come in here and say this. Else, if size equal M, we're going to put now you are a medium. All right, and let me add, let me add the other two here. All right, so we've got medium, we've got large, and we've got extra large. You better make sure to change what this says or else that's always going to say medium. So large and extra large. Again, when we run this right now, it's going to check this. That will fail, so it'll skip that. This will succeed, so it will print this, and since it's found a match, it will skip all of these. Does that make sense to everyone? All right. The way that this is written, now, as long as I put in either an S or an M or an L or an XL, as long as I put in one of those, either line 58 will hit, or line 62 will hit, or line 66 will hit, or line 70 will hit. One of them must hit. All right? But only one can hit. Does that make sense to everyone? All right, let's say I fat fingered and I did this. So now I've got an SS. Now nothing is going to print. Does that, oops, I'm sorry. Make this MM up here. Now nothing is going to print because there's no match. Does that make sense to everyone? Well, what if I want a match? So I can come down here and put in an else. Notice all the other ones are else ifs. This is just an else. So I'm going to say right line, invalid size entered. So now if we don't put in an S, and we don't put in an M, and we don't put in an L, and we don't put in an XL, it's going to print this. Does that make sense to everyone? All right, then next, if I put in this, if I put in a small s, nothing's going to print. It's going to fail all of these, and it's going to print invalid size entered. What if I want to be able to do this? All right, then I can come in here and say size equals size dot to upper. That is one of our string methods. That will converts the S to a capital S. Does that make sense to everyone? Now we could have changed this and used numbers instead. Not only that, I'm using equals here. You can use our less than or equal to, greater than, and greater than or equal to in here also. All right? Now, I just asked, and you all said that you got this. So I'm taking for granted that it made sense to you. All right? If you've got any questions, now's your time to ask. All right? Otherwise, I'm going to take this, and now I'm going to grab everything I've done so far, and it's now all commented out. But I'm going to bring back in here our sizes right here, this. Because I want to show you another way to write this. All right? So I've got that back again. I don't know why it commented. These shouldn't be comments, but they are, so I'll fix that in a second. I don't think I need this, so hold on. All right, so there's our logical operators. Oh, let me get back here. Somehow I screwed this all up, so let me get it so where it's working again. All right, so I've got that, got all that, and now I got to comment all of this out here. I did my comments backwards, my ending comment. There we go. Now everything's fine. All right, so here are my sizes again, but I want to rewrite this. It's totally fine the way it is. All right, but I want to rewrite this like this. I'm going to say, use what's called a switch statement. So I'm going to type in switch on size, and the whole thing has to be within curly braces. So I'm going to say case S. Let me grab all of this stuff, all my right lines, or just grab one of them here is fine. So I'm going to grab that. And let me just copy this down and make my associated changes. All right, so I've got my small. This will, in just a second, be my medium. And of course, then that'll have to be an M. This will be L, which will say you are a large. And this will be my XL, which says you are a extra large. It should have been and, but I don't really care. Extra large. And then finally, this will have the word default on it. And what did we say before? We said invalid size entered. So I've just gone back in here and I have rewritten this. So I rewrote this. I'll make it smaller, but so you can see all of it. I rewrote this right here. And it's what, 56 to 75, about 20 lines. And I rewrote it like this, 82 to 103. Again, it's about 20 lines. Sometimes people find this, sorry about that, sometimes people find this easier to read. Now, looking at this, the ifs probably made fairly at least made sense. When you use a switch, it has to be within curly braces. Whatever it is your cases are, have to be the same type as what you're switching on. That was a string, so this must be a string, this must be a string, etc. If I came through here and put in 37, it wouldn't make any sense to the system because I'm saying I want to compare 37 to a string. Invalid comparison. Now I could probably say 37, I never tried this, dot to string. I don't know why you'd ever want to do something like that, but it doesn't even like that. All right? So I'm just going to put in here back what it was in M. But the syntax for it, it's switch, and then in parentheses what you want to switch on, curly brace at the beginning and a curly brace at the end. And inside, you replace the if statement with the word case, and then you put what your case is and what you want to do. We could have put multiple lines in here. You know, I could have put in here int x equals 7, etc. It would work just fine. So you can put multiple statements in there if you want to or need to. When you want to fall out of that case, you put in the word break. Now, if I did not put in break, so for right now, I'm going to comment all of these out, and I'm going to pretend they're not there. Notice, right now, I'm getting errors. All right? And why am I getting errors? Because it doesn't know exactly what it is it's supposed to be doing. All right? So when you are done with a case, you must really always put the word break in there. Now, what if I did this? We're going to suppose for just a minute we've got different kinds of smalls. We got a small and we've got a petite small, let's say. So I'm going to say case PS for petite small. Notice I didn't get an error. I can have, if it's either one of these, it'll do this. All right? And this default is not mandatory, but the default here is like putting an else on the end of an if with an else if in it. You don't need it, but typically you do because it handles everything else. Now, I went through that kind of quickly, but my question to you is, are there any questions on either the if statement, the if else, the if else if, the if else if else, or the switch statement? All right, then I'm going to jump back to the book because I'm just supplementing what's in the book. They've got their own examples, and they're fine examples. I just want to show it to you in action, so to speak. All right? All right, so there's that. And here's the switch statement. Notice they used a similar thing, but, you know, as a discount percent. All right? And it's how to code switch expressions. Yeah. This is something fairly new. All right? And this is meant to be a shortcut. And it uses something that's called a discard, D-I-S-C-A-R-D. This is a fairly new feature. I think it'll even say when it was put in. C7.9, all right, and for case label C9.0. And since we're in 11, it's really within the last few years. Now, I'm not going to go over this right now because we'll look at discard statements in a lot more depth and breadth of coverage in a later chapter. So I will not test you on these. On the written test, it may ask you. All right? Just put down what you think it is, and if it's wrong, it's fine. All right? So we will talk about discard statements later. I don't want to go through it. All right, but it's just that they have other ways that you can write these, and they're fairly new. All right, I want to do one more thing right now, and after we do this one more thing, we're at 30 minutes, so we should be fine. I want to show you a conditional expression. So I'm taking for granted, because I asked, that everything that we've covered up to this point makes sense to you. All right? That's what I'm taking for granted. Now I'm going to go down here. So these were all commented out as I put them in. And I'm going to do something else. I'm going to say int num1 equals 71. Int num2 equals 118. These numbers mean nothing. And I'm going to have one more variable that says int max. And I'm not going to set it equal to anything. All right? I want to show you 3 different ways that we can set max. 3 different ways that we can set this. All right? The first one is kind of what you'd think. I could say if num1 is greater than or equal to num2, then max equals num1, else, put these, I'm just going, I made my font bigger, so I'm going to try to put these all on the same line like that, so it's, I can show more on the screen at once. Else max equal num2. Oops, num2. Now, you already can tell that max, when we get done, will be num2 because it's 118. I'm not going to insult your intelligence. You should all get that. That should make sense. But that'll work just fine. No problem with that. All right? But let's look at a couple of other ways we can do that. So I'm going to comment this out right here for now. All right? So that was the first way of doing it. I can also do that 2 other ways, and the advantage of each of these ways, it's only one line of code. All right, I can come in here and I can say max equal math.max num1 num2. We talked about this in the last chapter. And that will also set max equal to 118. But the next part of your book talks about what's called the conditional operator. So this is yet another way you can set this. So I want to show that to you. And that would say max equal, and I have to put the condition in there, so I'll say num1 greater than or equal to num2. Then I say question mark num1 colon num2. This is 2 things about this. First of all, it's also called the question mark colon operator, and it's called the ternary operator. Ternary means 3. We looked at, I'm going to come in here, I'm going to remove this right away. But if I say int x equals 7, you've already learned I can also say plus 7, or if it's negative, I can say minus 7. So using plus and minus in front of a value is what's called a unary operator. There's only one operator. The other stuff, like we did here, all of our relational operators that we looked at, all right, or I guess there are our relational operators, equal to, greater than or equal to, less than or equal to, and not equal to, those are called binary operators because there's 2 things. Here, since we have 2 operators, a question mark and a colon, we have 1, 2, 3 things. So what this does is it checks this. If this is true, it does what's after the question mark. So it takes num1 and it assigns it to max. If this is false, it takes what comes after the colon. So it takes num2 and it assigns it to max. That's called the conditional or ternary or question mark colon operator. So my question to you, no pun intended, is there anything in there that does not make sense to you? In this whole thing that I just did here, is there anything in there that does not make sense to you? All right, not hearing anything then. I'm again going to go down here and comment this all out. So everything I've done so far now has been commented out. Going back to our book momentarily. All right. They showed the conditional operator. They mentioned it's question mark colon. So you should be able to figure this out. Notice that I took what they show here and I put it in parens. In some languages, you must put it in parens. In C#, it's optional, so I put it in anyway. So this says check and see if subtotal is, in fact, this is the whole thing. Check and see if subtotal is greater than or equal to 100. If it is, it's going to set something equal to 0.1 m. If it's not, it's going to set it equal to 0.05 m. All right? So they show an example of it right here. Again, we could have done it as an if. All right? Or in our case, typically you can, or often at least, you can redo it as a math.max. Here's some more information on that if you're interested. All right, then we've got the enhanced version of the total application. It is 10:18. I'm going to go till 10:35, and then I'm going to take a break. All right, so that's this one. What's new on this one? Now you put the customer type in there. See that right there where they've got the R. And the customer type can be R, it can be C, or it can be neither of those. All right? And if it's R, they're going to get a certain kind of discount. If it's C, they're going to get another kind of discount. And otherwise, they're going to get yet another kind of discount. So the point is, notice we have what's called a nested if, which is an if inside of an if. That is totally legit in any programming language. You can have an if within an if. You can have an if within an else if. You can have an if within an else, for example. After the break, we're going to talk about the three major kinds of looping statements that are in C#. Those are a while loop, a do-while loop, and a for loop. You can have ifs within loops, loops within ifs. Loops within elses, elses within loops, etc. All the combinations. All right? Now, I do want to get into loops because that'll make everything hopefully a little better for you to understand. So one of the things I mentioned when we started today was we were going to talk about what is typically referred to as structured programming. And structured programming has three features. It has sequence, it has selection, and it has iteration, also known as looping. So what we've looked at so far in previous chapters is sequence, and that is doing one statement after the other in order, no varying. Order. So that's the first one. We had looked at that in previous chapters. Now we're into here. In fact, let me put this on a new line. It'll probably make it a little easier. All right. Now, today we just finished looking a bit ago at this. And this is either an if, or it's an if-else, or it's an if-else if, or it's an if-else if, and that's two words, I'm sorry, else, or it's a switch. So that's what we've looked at for those. After the break, we're going to look at, for now, there's another kind, but we're going to look at the three kinds of looping. And those will be a while loop, a do-while loop, and a for loop. So we are hitting all of the hallmarks of what is referred to as structured programming. All right? So like I said, I'm going to go till 10:35, even if I don't get all of this done right now. All right? Now, we don't care right now about this either. We don't care. I'm going to just remove this. All right? And this. Everything now is commented out. You've got all of this stuff in there, but everything has been commented out. And I'm going down. I'm already 130 lines down. All right? But all I'm going to do is create a simple variable. So I'm going to create a variable, and I'm going to call it number. And I'm going to set it equal to, in fact, I'm not going to set it equal to anything. All right? For the first one, we'll set it equal to 1. How's that? Now, let's suppose instead of number, this was test. And I'm going to say int test equal 1. All right? If I wanted to go and check this 100 times, I could write 100 different if statements or an if, else if, etc., etc., etc. But what I want to do is I'm going to make this back to number again, and I want to count from 1 to 100. I want to count right now and print out all the numbers from 1 to 100. All right? So I'm going to come in here and say this. While number is less than 100, and I'm going to put an error in here on purpose. All right? I'm going to put in right line number. Now, I'm not going to run this because if I did, I would go into what's called an infinite loop. It would keep printing out 1, 1, 1, 1, 1, 1, 1, 1, 1, 1 forever. And the reason it would do that is I'm never changing the value of number. And guess what? We learned how to do that in the last chapter by saying plus plus number. So if I put that in, and this is the first time with this, I'm going to come in and actually run this program. So let me do a file save all and run the program. Oh, I didn't have a read line at the end, so yeah, it's going to disappear. And notice, hard to read, I guess, there's all my numbers. Starts at 1, goes all the way down through, in this case, 99. I should have said less than or equal to 100, but you get the idea. All right? If I just said less than or equal to, it would also print 100. That is one way to loop through things. There can be as many statements as we need in here. We can put another loop in here. We can have if statements. We can have all the combinations of ifs. We can have a switch in here. All right? This will now run 100 times. It will do this. Now, let's talk about what makes this work. All right? There's 3 things that make this work. The first thing is we had to declare what's typically referred to as our loop control variable. And I usually call mine LCV because I call it what it is. LCV, short for loop control variable. So that's the first thing that we have to do, is we have to declare our loop control variable. All right? In fact, let me make this a little smaller, and I'm going to take that comment, instead of putting it above it, now we can leave it there, that's fine. Nah, let's move it. So we declared our loop control variable. The second thing we must do is we must test the loop control variable. And if the test is true, we do what's inside of the curly braces, what are referred to as the loop body, and if it's false, we don't. So in other words, if I change this to 0, like that, this would never run. It wouldn't do anything. Just to prove that to you, I'm going to save this, and I'm going to run the program again. And all I get is it's waiting here, and I'm done. But if I change it back to 100 again, whoops, not 1,000, 100 again like we had, and I run it, there's all my numbers, starting at 1 and now ending with 100. All right? The third thing we must do is alter the value of the loop control variable. All right? So those are the three major components of using a loop control variable. You must give it, whatever you're looping, telling it how many times, must have an initial value, must be tested, and must be changed. And I've already shown you this, but if I said a 0 here, it never ran, because a while loop is what's typically called a pretest loop. What pretest means is you check the value before you get into the loop body. If the value of the while loop is false initially, you never go in and perform the loop body. This will perform 0 times. This will perform 10 times. This will perform 100 times, 1,000, 10,000, 100,000, 1 million times. So I'm asking again the question, does what I just showed you there, does that totally make sense to everyone? All right, not hearing anything, I'm going to show you the next type of loop. All right, so I'm going to comment all of this out, but first I'm going to copy it. All right, and I'm going to take everything that was in here. Oops. That's fine. And I'm going to comment that out. Let's see what's, okay, that's this. So, come down to here and comment all that out. Now I'm going to put it right back in again. Why? Because I want to show you the next type of loop, which is a for loop. With a for loop, you don't have to do this. You don't have to do this. And you're like, well, wait a minute, you just told us you have to declare, yeah, but you do it all together. So I'm going to put in here, declare loop control variable, test loop control variable, and alter value of loop control variable. I'm going to put all of those up here near the top. All right, and I change it like this. So for int LCV equal 1, LCV less than or equal to 100, plus plus LCV. So we only have to do that. So before we had 1, 2, 3, 4, 5, 6 lines of code, including our curly braces. Now we have 1, 2, 3, 4 times, or 4 lines of code. I'm going to save this and run it again to prove to you that it still works. And now I've got an extra curly down there, so let me get rid of that. All right, so it should work now. And there's my numbers. Again, from 1 through 100. All right? And again, so what's the difference? In our while loop, we did the initialization, the test, and in our case, the incrementing on 3 different lines. In a for loop, you do it as 1 line. And just like a while loop, this is a pretest loop. So if I had put in here 0, it would never have ran. Just to prove that again to you, because it's not less than or equal to 0, I'm going to do a save all. I'm going to run it again, and you'll notice there's no output. All right? This will result in 10 lines, 1 to 10, 1 to 100, 1 to 1,000, 1 to 10,000, 1 to 100,000, and 1 to 1,000,000. I'm not going to write that. I mean, I could print it out, but it's going to take a long time. Literally, like that. I snap my fingers. That's how fast it gets processed, but actually outputting stuff to a printer is what takes the time. So that's that loop. Any questions on any of the loops we've covered thus far? Hearing none, I'm going to go and I'm going to do the last loop, and then we're taking our break. All right, so let me come down here. All right, and we're going to put in the last type of loop. And what I'm going to do is, because it's very similar to the while, I am going to copy all this, paste it in. All right. But now I want to change a couple things. Instead of while, it's a do while loop. And instead of being a pre-test loop, it is what's called a post-test loop. And we're going to take this thing, we're going to put it at the end, and we must put a semicolon at the end. Now, just to prove to you that this works, I'm going to save this, and I'm going to run it again. And you'll notice there's my numbers again, 1 through 100. So that didn't change. But notice that when I make this a 0, all right, in fact, that's not, I'll make that a 1. When I make my test here 0, this test is going to fail. But when I make that a 0 and I run this, notice what my output is. 1, and then it stops. Since it's a post-test loop, a do-while loop always runs once. Always. Even if the test is false to begin with. That is because it is a post-test loop, meaning that even though we declared the variable here, even though we altered it here, we're not testing it here. We are testing it there. Not there, I'm sorry. Let me move that up. We are testing it there. So sometimes what developers will do is they want to use a while loop, but they want to test, this might be error handling code. You know, stuff if something goes wrong. So they might run it so that it runs one time and then convert it back from a do while to a while. You normally see many more while loops and for loops in application code than you do whiles. Now that's my opinion. If we had a person in here who was working at company X, they might come in and say, that isn't true. Okay, that's fine. All right? So I have just gone over with you, all right, the 3 different kinds of loops. I want to say one more thing, and that is with a for loop is what's known as a counting loop. You must know where you're starting and where you're ending. But imagine for just a moment, I'll go till 1040, promise, that instead of counting like we're doing here, we have a whole bunch of, we work at an insurance company, and we want to read in a whole bunch of records for customers. Some of these customers have added, they're new customers. Some of them have changed their address or whatever, so we're going to modify them. Some of them either have passed away or they changed insurance companies and they don't want us anymore, so we're going to remove them. Well, if we don't know how many records we have in advance, we cannot use a for loop, because a for loop is also known as a counting loop. We can use a while loop. We can use a do while loop, because we could change this, so instead of testing for a number, we could say while, for example, not EOF, which means we haven't reached the end of our file. EOF is end of file. We could use something like that here. We can use something like that here. But we cannot use that in here. It doesn't make any sense to the system to do that. All right? So what we have covered then is we went through, talking about our 3 parts of structured programming. We did sequence in the previous chapters. We have just gone over if, else if, etc. All right, and switch. Now we just did while, do while, and for. Plus we started with relational operators, then went into logical operators. So in our chapter, we've now gone through. Now they give you other examples. There's absolutely nothing wrong with their examples. I wanted to do something and run it for you right away so you could see it. All right? Now, the only thing I have not covered, and I've got 3 more minutes because I said at 10:40 I'd give you a break, is, no pun intended, the break statement and the continue statement. So I'm going to cover those right now, and I'm going to demonstrate them to you. So I'm going to come back to where we were before, and, whoops, I'm going to go back and uncomment just the while loop stuff, just the while loop. Everything else will be commented out. So I want to come back to this while loop, so I'm going to come over to here and put in this, and then uncomment right here by the while loop with the read line, but then I want to comment all of this out again because it's easy to show you this with a while loop. All right, now I'm going from 1 to 100. You all see that. All right, but for some reason, I don't like the number 23. I have nothing against that number, but you get my drift. So I'm going to say if number if LCV equal 23, break. All right, so if the number 23 has been read, break. Watch what happens when I run the program. It goes from 1 to 23, and then it says, see, it added 1 to it there. That's why it says 23. It equals 23, so it breaks. So break, you saw this before where we broke out of the switch. Break gets you out of whatever you're in. So that's break. On the other hand, this one you'll have to look at to understand. If I type in the word continue there, all right? So if LCV equal 23, continue. All right? Now, let's do this. Let's take this right line statement, and let's move it down here. Why? You'll see why in just a moment. So I'm going to save that, and I'm going to run the program. And you're going to say, hey, everything worked. Well, now it's down to 22, but what happened? All right, it stopped. I'm not sure why it stopped. I think it was that read line that we've got in there. But with continue, what's supposed to happen is what I thought was going to happen right there. Let's see. Plus LCV. So it skipped that. All right, we'll do it like this. And we'll set it equal to 0 to begin. So I want you to see this before we break. Good. All right, so we've got all our numbers, right? The answer is no. If you look in here, what did it do? It skipped the number 23. Hopefully you can see that. That's about as big as I can make it right there. There is no number 23. All right? Why does that matter? It matters because when it hits continue, it stops what comes after this. So it stopped this. It does not do this. It jumps right back up, all right? And then it added to our loop control variable. So break breaks you out of something. Continue ends the current loop iteration and then continues on. So with all of that said, is there anything that we've talked about, including break and continue? Anything in there? And again, there's examples in the book. They're probably better than mine, but they give you break and they give you continue. Any questions on any of that stuff? Anything we've done so far? All right, I went a minute over, so I'm going to give you your last break now, because when we come back, we're going to finish this and write a very simple little program that'll show all of this stuff, and then we'll end. All right, so let's see if I refresh this. There we go. Come back in 10 minutes, please. Here, again, I know I've asked before, but this is your time to ask. If there are any questions on anything we've covered up till this point, I'll be more than happy to try to answer them. All right. Then I'm going to go on. It says here a for loop with a breakpoint and an execution point. Well, I'm not going to get into this right now because we're going to have a whole chapter where we go over, all right, we'll have a whole chapter where we go over how to create breakpoints. But I'll just literally give it to you the microencapsulator version, and that is this. If we went back to our program, and I know I've commented this out, but let's just say I uncommented this, and I put a breakpoint right there. Let's just say I did that. I don't know why I would, but let's just assume for a second that I did do that. All right? Then that breakpoint would actually stop 100 times, once for each time. I don't know why I'd want to do that if I put a breakpoint right here, but I could. It didn't like the breakpoint because I was trying to put one into a comment. It didn't understand what I was trying to do. All right. Don't worry about break mode. You probably have seen it already. The one thing to realize, all right, and this is one thing I should have probably mentioned earlier and didn't, but let's just put a line. Let's take out of here. We've got the read line. Let's take our do while that we put in here and let's uncomment this. All right, so we've got the do while back. Let me double check and make sure that no one's having any problems. Nope. Okay. So if I save this and run the program, all right, it's going to print all that out. That, no problem. Okay, we've seen this before. What I want to mention is this. When this red thing is showing right here, you are in run mode. You notice that you can't run because you can't click your run button because you're already in run mode. Now, this isn't as important in a console app, but I find myself doing it because if you are in a GUI app and you're like this where you're running the program, sometimes it'll let you enter code and sometimes it won't. You really should never enter code while you're in a run mode like this. Whether you can do it or not, you should stop the run mode, all right, get back out so you're right here, all right. And it may not sound like a big thing, but sometimes it is. All right. All right, we're just about finished with the chapter, I believe. So the last thing they talk about in here is this future value app. And it's good because it actually gives me some time to talk about it. All right? Again, I've been throwing a lot of stuff at you. And at least one, and actually more than that, of the people who are taking this course and are watching the videos every night have emailed me and said, hey, are we going to be meeting like 3 frickin' hours with listening to you talk every day? Well, you already saw that you weren't. All right. You already know that Monday of next week we're off, but on Tuesday of next week we're going to do a couple of problems together. Wednesday and Thursday will both be labs for the entire period. All right. But when I got a lecture day like this, when I'm giving you all this stuff, so right now you've had, on the YouTube video it's going to be an hour, a little over an hour, but I also went for a good hour and a half or something like that going over the test. All right. So the point is, if we very well will be done, we'll probably be done by 11:30. All right. And that's even going through this future value and probably looking at something else too. So the future value app, just so you see it, it's right here. In English, what they're saying is, if I invest $100 a month for 10 years, which means what? 12 months in a year, so 12 times 10, 120. All right. So that would be $12,000. If I do that at 7.5%, at the end of that 10 years, I should have made $17,904.24. So that's what they're saying. All right. What I'm going to do is I'm going to build this for you. And we're going to put their code in, but we're going to put it in incrementally. So what I'll do here is go back to my program, and I'm going to do a file, save all. And I'm going to come in and add another solution. I'm sorry, add another project. No, not another solution. Right mouse click, add new project. This one will be a Windows form. .NET. And we will just call this what it is. How about Chapter 05 Future Value? All right, a little big, long for a name, but it works. All right, so I've got that. Now, just because of the fact, I guess it's age creeping up on me, unfortunately, but I'm going to do this, and that is, let me grab this and this, print screen. Oh, do that again. That's fine. All right, so this is what I want to build. I just want to be able to go back and refer to that. So we've got what? 1, 2, 3, 4 text boxes, 1, 2, 3, 4 labels, 2 buttons. As we always do, I'll add a clear button in there also so we can run this thing repeatedly. All right, so let me go and quickly build this. We said we were going to have 4 labels. So I'm just going to put in 1. You've seen me do this before. We're going to have 4 text boxes. I'm going to put in 1. And we're going to have 3 buttons. And again, I'll put in 1. Now, you've seen me do this several times before. I'm going to highlight all 3. I'm going to come in to font, and I'm going to make it even bigger than we usually do. I'm going to make it 18, bold, and Arial. So we've got that now. We've got the beginning of our interface made. All right. The button's a little thick right now, so I'm going to cut it down like that. And here will be my 3 buttons. You already know what all this is. So I'm going to very quickly set up my interface. So BTN calculate. And this will say calculate. BTN clear, and this will say clear, and finally our exit button, which will say exit, and we will, oops, I didn't change, so that's dumb. Let me make that clear again. All right, and then our last button, which will be BTN exit, and we will put in the code, or the text there, exit. All right, so our buttons are done. This label, I want to make this bigger. It's totally fine like that, but I'm going to take this label. Now, this has to say what? Monthly investment, etc. So that first one is going to be the longest one that I have. So I'm going to come in here, and this will be LBL, monthly investment. And it will say monthly investment with a colon. All right, so that looks pretty good. All right, so I should be able now to come in, copy that, paste, paste, and paste. So you can see how quick I set up my interface. Not to impress you or anything. I don't think it's impressive. But I just wanted to get everything done right away. Change the color of my form, the background color. Let's make it this, whatever that is. All right, so we pretty much have got this made now. So I'm going to highlight everything. I can either draw that invisible lasso around it, or I can do click on the form, do a Control-A to highlight it all, and I'm going to lock my interface. All right, so this button is done, this button is done, this button is done. That's done. It says TXT monthly investment. I want this one to, I'm sorry, this is LBL monthly investment. I want this to be TXT monthly investment. All right, my second one is going to be, not that, that was an old thing. Don't need that anymore. Yearly interest rate. So that's what this should say. So we'll make it what it is, LBL, yearly interest rate. All right, and that's what the code will say too, will be yearly interest rate. So that's what the text on the button will be. I made the N in interest accidentally capitalized. All right, and I've got that in my name. I don't like that, so I'm going to fix that. All right, and this will be TXT yearly interest rate in a matter of seconds. So click on there, and that's TXT yearly interest rate. Well, that's good. What's left? Number of years and then future value. So this will say number of years, so it will be LBL number of years. And again, that's what the text will say, will be number of years. The text box will be TXT number of years. And then finally, this last one will say future value. So this will be LBL future value. And it will say future value. All right. And I think I changed that one, yeah. This will be TXT future value. Again, and I'll change the name of my form. So I'm going to right mouse or click on my form, right mouse click over here and choose rename. And I'm going to make it FRM future value. So yes, I do want to change all that stuff. Boom. All right. Very quickly, I'll click on here and I'm going to go to my view tab order. And that will be 0, 1, 2. This will be read only in a moment. So 3, 4, 5, 6, 7, 8, 9, 10. I'm going to do another view tab order. All right. Then click on my form and I want to change 3 more things and then we're ready to get going. The first is I want to set my accept button to BTN calculate. I want to set my cancel button to BTN clear, and I want to set my Windows start position to center screen. All right. All right, so if I run it now and there's no code in it, whoop, I didn't set my startup project, so we'll do that. Set a startup project. And there it is. Should be able to tab through it, etc. right now. Good. It looks good, as far as I can tell, and it's centered. That's good. All right. Next, and you've seen me do this multiple times, I'm going to go back to here, and I'm going to search for exit button. There's that code. I've explained the exit button several times, so I'm not going to again, but I am going to put the code in there for the exit button, so that's in there. Now, what do we want to do? We want to, when we click clear, we want to clear, 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 and put our focus right there. Before I do that, I'm going to click on future value, and I'm going to set the read-only property on that to true. That turned gray. So for clearing, txt monthly investment dot text equals double quote, double quote. Let me move this over. TXT, what was it? Yearly interest rate. No, wrong one. Didn't. TXT, try it again. Yearly interest rate dot text equals double quote, TXT number of years dot text equals double quote, and TXT future value dot text equals double quote again. If you want to, you can add these or line these up like little soldiers. You don't have to. And then finally, TXT monthly investment dot focus. All right. So let's make sure that both our clear and our exit buttons work. So I'll just put some garbage in here. Click clear. That works, and my cursor is blinking in there. Exit. no, exit, yes. All right, so all that stuff is done. Now I'm going to switch back to the book, so because I'm going to use their code rather than me having to go and code all this stuff up. All right. So we just built the interface, except ours, the only difference is we have a clear button. I didn't use their names, but that's no biggie. All right, and they say the text align, set it to middle left, and the tab index, well, we already set the tab index. The only other thing, and I've told you before, I like to do this, you don't have to, is to highlight all of those fields right there, go down to text align, and now it's left justified. I'm going to change it to center justified. All right. So now I'm pretty much in jive with what's in the book. So they want the code for the form. Let's look at it, and then we'll put it in a bit at a time. This is the calculate. Now, for their exit button, they just close. So they don't ask you like I do or like we do you want to close? All right? But they've got all the code here, and of course, it's not going to let me copy it. All right? But I do have it, so let me grab that. I just want to grab it. So, in my opinion, right or wrong, you watching me code things is kind of a waste of both our times. Let's see. So I'm just going to grab all of the code that was put in here for the future value, and just the code for the calculate button. I'm going to grab those 10, 15, 20 lines of code, and I'm going to copy them to the clipboard, and then I'm going to paste them into my program. They probably use different variable names than me, so I'll probably get some errors, and that's fine. We'll go back and we'll fix those momentarily. All right, so what didn't it like? All right, I used yearly interest rate, and they just used years. No, I used number of years, and they used years. So this should be number, darn it. This should be here, number of years. All right, and that's the yearly interest rate that I called yearly interest rate. So that should fix that. All right, so I used most of the names that they used. Let's try running it, and we'll go back and we'll decompose it. We'll look at every bit of it in just a moment. All right, but what I'd like to do first, like I said, is to run it, and once we run it, I'm going to put in their numbers and see if it works the same. All right, hopefully, like I said, my names and stuff are okay. Then we're going to look at every line that's in here. All right, so they used, in their example, 100, 7.5, and 10. So I'm going to run this. 100, 7.5, and 10. And we calculate, and we get 17,904.24. I believe that's what it was, but let's double check. 17,904.24. Good, it works. All right, so let's break this down now. Hopefully, I won't have to talk about the clear button anymore. You get it. I don't have to talk about the exit button anymore. You get it. But let's talk about everything else that's in this routine. And it's not long. It starts, the first line of code is 22, and it ends at 37. So a little more, maybe 15 or 16 lines. All right? Now, what you have to start understanding here, if you don't, is what these lines here are doing to begin with. All right? So I'll put a comment here that says convert text box values to their equivalent program variables. So in other words, in these three lines, we're saying take what you put in here and convert it to a decimal. Take what you put in here and convert it to a decimal. Take what you put in here and convert it to an integer. Does anyone have any questions about that? All right. Then next, we have to figure out the total number of months. That's taking our years and dividing it by 12, or multiplying it rather by 12. So calculate total number of months. All right. Now the next line may or may not make sense to you, but if we put in here, if you remember when we ran this, we put 7.5 in there for our interest rate. That's our yearly interest rate. What we need, though, is we need to calculate that interest rate every month. So we're taking that and dividing it by 12 and then by 100. The order in which you do these two divisions doesn't matter. This is taking the 7.5 and dividing it by 12 and then by 100. So it's doing a monthly interest rate. So I'm going to put in here, calculate monthly interest rate. All right. Now we're about to come in and do the big stuff. Initialize current future. I'll do it like this, being consistent. Value to 0. Okay. Now we have to loop through this for each month. And then I'm going to put in here example. If years equal 10, then months equal 120. So we would have to loop through 120 times. All right? This is a calculation. I mean, honest to goodness, don't let that worry you. You say, well, I don't understand what's going on there. You know what? I don't because I don't care. That's not what's important. If you ever get something like that on a test, we'll give you the calculation. Because, again, that's not what's important. What's important is, are you able to set everything up? So it's going to be calculating the future value for month 1, then for month 2, then for month 3, etc. And the reason that this is important is it's when it goes through once, it's got month 1 in here. Then it's got to figure out that for month 2. Then it's got to do that for month 3. When it gets done for the very last time, they use I, and I used LCV here for loop control variable. This is considered the only time in programming when you've got variables for your loops like this that it's okay to use IJK, etc. All right? But I'm still using the LCV. So this will actually go through this 119 times. 120 times. The first time at 0, the second time at, or the last time rather, at 119. I could put in here 1 and let's say less than or equal to months too. Either way it would work in there. But I want to go through this once for each month. Now, when I'm done, it's got that $17,924 and some odd cents. I want to throw that into the bottom text box, and then I want to set the focus back to my first field so I can do it again. All right? So, my question to you, because I went through that quickly, as always, is there anything in the code here that does not make sense? Oops, that was stupid. Let me try this. Text box. All right, so that's everything. There's nothing else to really talk about in here. All right? Now, before I finish up, because it's 11:16, I said I'll get you done by 11:30. So first of all, again, you already know this, but we don't need any of these. You can leave them in there. It doesn't hurt anything. All right? And I should put some kind of a prologue in here. So before I send this out to you, which I'm going to do in a little bit, it'll be this afternoon, I'll put a prologue in there. I started putting in comments. I usually put in something like, this code runs when the calculate button is clicked. And then I usually take it and copy it and come down here and say this code runs when the clear button is clicked. And then finally, this code runs when the exit button is clicked. All right. So I've got all that. I want to go and add some kind of a prologue. I'll grab something that they have from the book probably. All right. But I want to do this. We looked at this a little yesterday. Since we've got 10 or 15 minutes right now, let's look at it now. So these are your labs for Chapter 4. They're all GUIs. The first lab asks you to do a GUI program. All right. And what you can do is you can either put a value in for miles and click this and have a value pop in for kilometers, or you can put in a value for kilometers there, click the convert to miles, and have a number pop in there. All right? So my hope is I didn't go through that too fast and that it makes some sense to you. If it doesn't, this is your time to ask. All right? So that was the first one. Then next, this is the one we'll do as a class. All right? So if we put in 127, all right? So these are 4 different chickens laying eggs. Chicken 1 laid 40, chicken 2 laid 23, chicken 3 laid 36, chicken 4 laid 31. If I add these up, 40, 23, 36, and 31, it's 127. Well, there's 12 eggs in a dozen, so 127 divided by what? Divided by 12 equals 10. There's our dozen. 127 modulo 12, all right, is going to give you 7. So that's how we do that problem. So we'll do that as a class. All right, I'll ask you to try to do this one. It'll be a little bit more work, but it should be much easier to lay this out because you're doing it in a GUI format, whereas when I did it for you last week, we did it as a console. All right, so that's your labs, I should say. These are your labs for Chapter 4. Let's come in and look at I think is this what we just brought up? Yes, it is. These are your labs for Chapter 5, what we covered today. So you want to come in here and you want to put in 2 things. Label, text box, button, label. Or you could make that a read-only text box. It's your call. But put in a GPA, put in an admission score, check both those, so it'll be an if statement in here. After you click admit, and it'll either say accept or it'll say reject. All right? Then come down here, you'll put in a wind speed. You know, just put in some number. You'll click estimate. If it's 157 or above, it'll say category 5. If it's 130 to 156, it'll say category 4. If it's 111 to 129, it'll say category 3. If it is 96 to 110, it'll say category 2. All right. If it's 74 to 95, it'll say category 1. And if it's less than 74, it'll say not a hurricane. All right. So you'll be using ifs in here. You will not, it does not make any sense in there to use a switch. I didn't mention that before, but with the switch we did, that was a good case for a switch. But if you remember, for example, when we did the grades program and we checked and we said if the number grade is greater than or equal to 90, then the letter grade is an A. You wouldn't want to do that with a switch because you'd have to do a switch and you'd have to have a case 90, a case 91, a case 92. You'd be writing out 100 or more of those cases. That would be silly. All right. Then finally, this is the one we'll do as a class, rock, paper, scissors. And this will invoke a couple things. All right. The computer will automatically pick rock, paper, or scissors. Once we pick rock, paper, or scissors, it'll let us know. So if we pick rock and the computer picked paper, this is the message that'll come up. And the computer will have 1 added to its score. If it was reversed, it'll say the same thing here, but it'll add 1 to our score and nothing to the computer score, and it'll say instead of computer wins, it'll say player wins. If we both pick rock, it'll say something like both picked rocked, and well, player score and computer score, we'll say tie game. We'll even add a tie in here so we can count ties. All right? So those are the labs for Chapter 5. So let's quickly look at the homeworks. Wrong button. Try that again. All right. So this first one was this area and perimeter. This is this is simpler than what I just showed you in the future value program. So we won't do that one. This one's a little harder because it says add, etc. So it's accumulating test score data. So we'll do this one together as a class. And we will add in here, we've got the add, so that's fine. So instead of where I call calculate and putting it down here, they're putting it up there. That's fine. We'll do it, we'll make it look just like theirs. For Chapter 5, I'm going to want you to work on this one because it's going to take some thought. All right? It's not that I can't do it. I've done this program already, but I'd like you to give this one a try. All right? And we will do the calculate change one as a class. Okay? In fact, this one is real similar to the egg one, so maybe we won't do that one. Maybe we'll do this one. And if you say, what do you mean it's similar? Let's say that, I'm going to give you a quick example just so you see it. So, oops, I want to knock this way down in size here. Like that. New. All right, I'm going to give you a quick hint for this one right here. So let's say for the amount of change, we put in 89, meaning it's 89 cents. Well, to figure out the number of quarters, it'll be 89. Oh, I don't know what I did there, but I did something stupid. So what it's going to be right there is it's going to be 89 divided by 25, and that's going to give you 3. We're not worrying about the remainder in this line of code. So there'll be 3 quarters right there. But then if we do 89 modulo 25, that'll give us the remainder. So what's left? Well, 89 minus 75 is 14. Then to figure out how many dimes we have, we'll take that 14 and we will divide that by 10, which will give us 1. And to find out how much change we've got left, all right, we'll say 14 modulo 10, and that'll give us 4. To find out how many nickels we have, and we don't have any, so 14 divided by 5, 4 divided by 5. All right, we don't really even have to do this, all right, but that gives us 0. So what's left? Well, if you do 4 modulo 5, it gives you 4. So there's the number of quarters, there's the number of dimes, there's the number of pennies. All right? Now, there's a little more to it than that, but I don't want you to use the actual numbers. I want you to give them names. Call this total change, call this quarters, call this dimes, call this nickels, call this pennies, etc. But maybe we'll do this one because it's a little harder one as a class. All right? And then that'll be it. Also, please remember, all right, that you must go in. You've got all this stuff. So let me go back to here. And you must also, by a week from Sunday, do the written tests for Chapter 4, all right, and for Chapter 5. Guess it didn't open 5, so let me open it. And there is the one for Chapter 5. So again, to summarize, one last thing, and that is what I showed you earlier, meaning, I'm going to get rid of, I bet you I removed it. If I did, I'm silly. Nope, there it is, good. All right. So make sure by this Sunday at midnight, I'm probably going to grade these Sunday evening. As long as it's got a midnight timestamp on it, it's still considered good. Whatever I don't grade, I'll grade sometime on Monday, hopefully. All right? But for Sunday, make sure you've got those written tests, and I'm giving everybody credit for those because we did them together. All right? We did these, but I do want to make sure you've done those. The class is not about memorizing stuff to put on a written test. The class is about being able to do homeworks and labs and hands-on tests. So I will check this for everybody. All right? And next week on Monday, no class, Martin Luther King holiday. On Tuesday, we'll go over pretty much those problems I just told you we'd go over, however long that takes, and we'll take our time doing it. Wednesday will be lab for the entire period. Again, I will be online. So if you've got questions, you can email me, or if you're brave enough to talk where the other students can potentially hear you, all right? Okay, because it'll be taped. All right? Thursday will be another lab. Friday will be the pretest. Then a week from Monday on the 24th, you will have your hands-on test. All right? I can't think of any other way to prepare you for that. And again, finally, this work that's right here will be due on the 23rd of January. This work will be due on the 23rd of January. The work we've done so far is due, so this work is due this Sunday. All right, so I know, again, I've asked this multiple times this period and during different sessions of this class. The people who are here listening live right now, are there any questions on any of the stuff that we have gone over today, or before today for that matter? Okay? Last thing I'll tell you, then I'm finished, and that is, again, I am not meant to be a replacement for your book. One of the reasons that we give you the written tests is because you probably could get through the book without using the book. You could probably do the most of the other stuff. All right, but we're forcing you to read the book because that's what you need to answer the written tests. All right, I'm meant to supplement what's in the book. I'm hitting the high points and going over what I feel is important. All right, if there are no other questions, it is 11:30. Have a good weekend. I will talk to all of you on Monday. See you then. Or Tuesday. Sorry, not Monday. I will talk to you all on Tuesday. See you then.